Hey students, this is Mrs. Tran-Bloom. Are you excited to graph square root functions? That's what we're starting. Okay, so obviously the name square root, it's in the title, so we are graphing square root today. The parent function is y equals square root of x. Now the HK form is the same as always before. It is f of x equals a, it's in front of the square root. Now if it's other function, you guys remember seeing it in front of the parentheses, right? The h is the translation of left or right, and the k is the translation of up or down. So if you guys have a negative h value, then this is going to go down. Oops. This is going to go left. If you guys have a positive h value, then it's going to be the translation to the right. Okay. Now, similarly with the k value, if it's a negative k value, we translate it downward. And if it's going to be a positive k value, we translate it upward. So same exact transformations as before. Now, and then we have a value. So the a has kind of three things here, right? -1, it's a reflection over x-axis. Or sometimes we refer to this as a vertical reflection. Then now, if it's a 1/2, 1/3, whatever that is, right? It's a fraction. So if it's in between 0 and 1, then it's going to be a vertical compression. Now, if it's bigger than 1, then that's going to be a vertical stretch. Okay, so 1.5, that's bigger than 1, so it's going to be a vertical stretch. Now, if you have a 3/7, that is in between 0 and 1, so that's a vertical compression. Okay. Now let's start with the basic parent function. Parent function for y equals square root of x, as you guys know already, we cannot have any negative numbers under the square root. So we will start with a nice number, 0, because that's the smallest x we can have under the radical and still be okay. Then we are going to pick nice square numbers such as 1, 4, 9, and 16. Okay. Square root of 0 is 0. Square root of 1 is 1. Square root of 4 is 2. Square root of 9, it's going to be 3. Square root of 16, it's going to be 4. So let's plot it. 0 is 0. 1 is 1. 4 up 2. 9 up 3. And if you are ever out of tick marks, you can add a few more. 11, 12, 13, 14, 15, 16, and then we're going to up 4. So this is what it looks like. Oops, that's not supposed to happen. Now, I missed my dots, so I'll make it really fat. Anytime you miss your dots and you want to show your teachers that you know how to plot, just make the dots bigger. So as you can see, this is back in the days, Mrs. Lassner used to call it the eyebrow curve because it looks like we have one eyebrow, right? So here's your eye, don't draw the eye, and let's pretend you have green eye. So there you go. So your one eyebrow curve, all right? So square root function, Mrs. Lassner, if you ever hear Mrs. Lassner, she call it the eyebrow curve. Okay, so h and k, because it is the parent function, it is going to be 0, 0. X-intercept, we have 1, is going to be 0, 0. Y-intercept happens to be at the same spot. Now, as you can see, the domain is going to be inclusive from 0 all the way to infinity, or you can write x is bigger than or equal to 0. The range is also bigger and equal to 0. So 0 all the way upward, or we can call it y is bigger. That doesn't look like a y. Y is bigger than or equal to 0. Now, as you can see here, the graph is always increasing, and it's increasing on the entire domain. So meaning that every single x value is increasing. that means you have nothing left for decreasing, because if every single x value is on the increasing interval, then nothing else is left over. It is definitely a 1-to-1 because it passes the horizontal line test, right? So whatever horizontal line we make, it only intersected at most one time. We have a minimum value. Minimum means lowest. So the minimum value is right here at the origin. So minimum value is 0 at x equals to 0. Now, anytime we're asking for the minimum value, it's normally the y value. Now, if we say where is the minimum at, then that's the x location. Since we do have an arrow means it goes up forever. That means there's no maximum value. All right. Hopefully, all of that is coming back to you guys. So transformations refresher, look at that. And we just wrote something just like that on the top, right? If A is negative, it's a reflection over x-axis. Or vertical reflection. Now, if an absolute value of A is less than 1, and we talked about this before, then it's going to be a vertical compression factor of whatever that is. If it's 1/3, then it's vertical compression of 1/3. If it's 9/10, then it's vertical compression of 9/10. Okay. If it's bigger than 1, it's a vertical stretch factor of, oops, why do I write 1/3? I meant whatever that is, 1/A. Okay, whatever A is. Factor of A. How about that? Factor of A. Okay. All right, so H. So as we stated earlier, if it's a negative H, translate to the left. If it's positive H, translate to the right. Negative K, go downward, okay? Positive K, translate upward. So just like what we talked about. Steps to graph any function in HK form. You're gonna see this a lot. It's the same every time, right? Number 1, identify the parent function. That's super important. Your function with the transformations should look very, very similar to the parent. Make a table of values for the parent, okay? Identify A, H, and K so we can state the transformation and use it for our new transform table. List the transformation from the parent. Make a new table of values using the transformation, A, H, and K. So x is now going to be changed to x plus h. The A and the K, because they're vertically changing, it goes with the y. Plot your new points. And then normally we ask you a bunch of questions regarding the regarding the graph. Let's go and practice. Let's see. Let's scheme ahead to see how many we have to practice all together for this set of notes. Looks like only 2. Amazing. Okie dokie. So first, remember, let's try to remember the A, H, and K. Where does A go? Where does H go? And where does K go, right? So, and again, this is meant to say X, guys. I'm sorry. Okay, X minus H. So A is in the front. So currently we see a 3 in the front. So that's a 3. It's going to be, this is minus H, okay? So this is going to be X minus a negative 6 inside the radical. So as you can see, H is a negative 6. And K is on the outside, and that's negative 4. That allows us to go down here and state the transformations right away. We have 3. A, H, and K. A is 3, so it's a vertical stretch factor of 3. H is negative 6, so left 6 units. K is negative 4, so down 4 units. Let's start with the parent function. Parent, it's going to be y equals square root of x. Get 5 values in there. it is a square root function, so you want to use square numbers, right? Perfect square numbers. So 1, 4, 9, 16. Usually 5 values is more than enough. Then we want to get square root of 0 is 0. Square root of 1 is 1. Square root of 4 is 2, 3, and 4. Then our transform, I'm going to get a different color pen. The h is going to be, okay, so x minus 6. So the h is going to go with the x. The a is going to be multiplied to the y, and the k will be, oops, it's going to be minus 4. All right, let's transform. So what I want you to do is take all of these x's right here and give me 5 new inputs. Then take all of the parent outputs and give me 5 new outputs. All right, take about a minute to do both new inputs and outputs for me. All right, hopefully you guys have our 5 new inputs and 5 new outputs. So let's start with the inputs, okay? 0. 0 minus 6 is going to be negative 6. 1 minus 6 is going to be negative 5. 4 minus 6 is going to be negative 2. 9 minus 6 is going to be 3. 16 minus 6 is going to be 10. Okay, let's go to the outputs. 0 times 3 is going to be 0. Then 0 minus 4 is going to be negative 4. 1 times 3 is 3. 3 minus 4 is going to be negative 1. 2 times 3 is going to be 6. 6 minus 4 is going to be 2. 3 times 3 is 9. 9 minus 4 is going to be 5. 4 times 3 is 12. 12 minus 4 is now 8. So now that we have our table here, let's plot. Negative 6 is going to be negative 4. So there's negative 6, negative 4. This was supposed to be negative 5, sorry. Negative 5 is going to be negative 1, so it's right there. Negative 2, go up 2. Positive 3, up 5. And positive 10, go all the way to 8. So there are the new points for our radical function. So now that we have it all graphed out, let's find the details in the chart here on the right side, okay? So HK, you guys already know we have those from here. That's negative 6 comma negative 4. X-intercept, right guys? So right now, we don't know what exactly the x and the y intercepts are. We will do those algebraically. So do not eyeball them if you're not exactly sure, okay? So x-intercept is when y has to equal to 0. So we are going to go, okay, well 0 equals 3 times the square root of x plus 6 minus 4. And we solve for x as we would always by first add 4 to both sides. After that, we will divide both sides by 3. Your goal is to isolate your radical. So if we divide both sides by 3, we now get 4 over 3 equals square root of x plus 6. Now to undo the radical, we now would have to square both sides. So this is going to become 16 over 9 equals x minus 6. I'm sorry, x plus 6. Next, we are going to subtract 6 from both sides, which I'm kind of out of space. So I'm going to move over here. So we are going to have x plus 6. Now we are going to subtract 6 from both sides. We do need to find a common denominator. So the common denominator of this would be 9. So we are going to multiply this by 9 and this also by 9. That's 16 over 9. 6 times 9, that's going to be 54. And the denominator are now common. With that said, 16 minus 9, that's going to give us 38 over 9, and 54 is negative, so we want to make it a negative 30 over 9. Now you always want to check to see if that's reducible. Now since we can't reduce that anymore, student, that would be our final x-intercept value. Now feel free to rewrite it as a mixed fraction as well. If we were to rewrite it as a mixed number, this is negative 4 and 2 over 9. So write it as an order pair. Okay, x and y intercept will always be an order pair. So that's going to be negative 4 2 9 comma 0. Y-intercept, and again, we can't eyeball the y-intercept, so we do have to solve it algebraically. Y-intercept is when x equals to 0, so it's going to be y equals 3 times, plug in 0 for x, plus 6, and drop down your minus 4 on the outside. So y equals 3 times radical 6 minus 4. We don't need a calculator, we can just leave it as is. So x is 0, y is 3 rad 6 minus 4. Okay, since we don't need to use a calculator, we can always leave your answer as an exact. Now the domain, remember we talked about the domain already, meaning all values of x. In this case, the smallest x that we have is -6, so it will be from -6 all the way to infinity, since the arrow goes to the right. Now the range, the smallest range we have is -4, and the arrow goes upward, so it is going to be from -4 all the way to infinity. As you can see, this is your radical function, and remember we talked about the eyebrow curve, so it's always going to be increasing unless we have a reflection. So it is increasing over the entire domain value. Since every single domain value is increasing, you have nothing left for decreasing. And yes, it is 1 to 1. We do have a minimum. The minimum is going to be the y value, which is -4, and at, if we ever ask you what the at, then it's x value. We do not have a maximum since we have an arrow going upward. So students, that is all of your example dos.